Hello and welcome to a video from the Aerospace Working Group of the ELISA Foundation. Today, we would like to show you some of our use cases, and in particular, a very easy use case you could start up with showing how we intend to create a minimal Linux kernel that can be used in aerospace. We set up the stage as following. On the left-hand side, you see an explanation of the use case that I will explain in a minute. And on the right-hand side, you see a standard Linux shell, which in that case is based on Ubuntu, which is running in a Windows Linux subsystem on a Windows host. But any other Ubuntu distribution or any other Docker-based Linux system should do it in the same way. On the left-hand side, you see links into our ELISA Aerospace Working Group JIT repository, which consists of an explanation of the use case. You will find this in WG Aerospace docs use cases, use case cabin lights. And later on, we will switch to the instructions that you can also follow the steps that we are going to present. The aerospace use case is basically showing how you would set up a minimal kernel distribution, and is based on a use case that is controlling cabin lights in an aircraft. It demonstrates how those applications would run based on a Linux kernel, and it measures whether the cabin lights control application is executed properly within a certain time frame. What will happen is that we will have an architecture that looks similar like it is described here. So you would have a switch, you would have a cabin light as a sensor and actuator, you would have a computing device platform, which would be based on Linux operating system. And we envision that those applications talk via an Ethernet bus with each other. Then you have several applications, all described in more detail here. So the switch application, the cabin lights application, a logging application, and a monitor application. And then you have several scenarios and options that you can consider to enhance on, but this is out of scope for today. Basically, what we will show is how you set up the stage to have a set of applications listed that is connected like shown here. So basically, there are the applications that I just mentioned, the switch application that sends a state message through Ethernet to the cabin lights applications. If you turn on the lights using the switch, the cabin lights application is supposed to actually control the cabin light. And this is being supervised by a monitor application that ensures that a certain time framing is as it was designed and intended to be. I'm now switching to the tab which shows the instructions on how to come to that setup and how to actually have those installations installed for you locally and for you to try. First, we have opened up a shell of a certain user, and we are just in a user workspace. Now we clone the JIT repository of the Aerospace Working Group, which downloads all the necessary files to actually create a container in which the demo is running. As a second step, we switch to the folder that actually contains all the different applications and the instructions on how to build them. The instructions are Makefile based and build scripts. So we start with a make prep step, which basically pulls from the internet a Docker container that contains all the different items that we're going to use in a minute. Basically, if you do this the first time, it will download it for some amount of time. All the further times will be quite fast because the container is then cached on your machine. Next, we will run make to actually download what is required and build the applications which are based on C mostly. Once this is done, we switch to the next step, which actually runs all the applications required in an environment called TMUX, which will have 4 sub-windows as shown on the left-hand side. And to run this, you basically just hit or type in make run. Now you end up in the demo as it is supposed to look like. So basically on the left-hand side, upper left-hand side, you have the monitoring application running. On the upper right-hand side, you have a light server application running. On the lower left-hand side, you have the syslog output file, which is basically the monitoring application's output, looking into is the switch actually turned on and turned off correctly. And on the lower right-hand side, you have the switch application already prepared to run. In the TMUX environment, to basically change the windows, you have to hit Ctrl B and then use the arrow keys to switch to the windows. Now the lower left is active. I want to switch to the switch application, so I press Ctrl B, hit arrow to the right, and then the command is already written there, so I can just hit return to actually run the switch application. And what will happen now, you will see on the left-hand side in the log that the switch is triggered, and after the switch is triggered, the lights become triggered as well. In that demo, we set up a violation of the timing constraints at a certain amount of time, and you will notice this in the right-hand side, which will be detected by the monitoring application that the light switch does not fulfill the timing requirements as intended. If that happens, the demo is basically done, and now you could investigate further into aspects like how is the minimal Linux kernel actually set up? What do I need for the applications to run? What resources do I need? And of course, you can also continue with enhancing the application or look into other aspects like multiple application, multiple hosts, or similar. Thank you for watching.